Hello, Mr. Springer back here again. Miss Goobrood's gremlins are still in her computer, so I'm doing Unit 3, Lesson 9 for you. I can recognize multiplication links. Start to really work on getting an understanding of what multiplying with fractions really means. It makes it so much easier. All right, so we're going to do it by predicting how the size of a fraction factor will affect the size of the product relating to the other factor. So it's basically thinking about how large will my product be? Am I going to have more or less than what I started with? All right. Now, I have a little diagrams that I think help people look at something. If I had 2, 6 plus 3, 6, I add my numerators and I have 5, 6. But when I'm multiplying 2, 6 by 3, 6, I multiply numerators and I multiply denominators, I get 636. Or I could factor first. There's 2 2s, or there's 1 2 and 2, and 3 2s and 6. There's 1 3 and 3, and 2 3s and 6. And I get 1 multiplied by 1 is 1, 6. Now, as I look at this in diagram form, 2, 6, excuse me, 1, 2, plus 3, 6, 1, 2, 3, 6, give me 6, 6. But 2, 6 of 3, 6 is 2 12ths. So I shouldn't have simplified this quite as far as I did, I guess. 1 6 is also equal to, multiplying by 2 and 2 would give me 2 12ths. So that shows how adding fractions gave me greater, but multiplying fractions gave me less. Look at, when I multiplied by and when I take 2 6 of 3 6, I have less than 3 6. And the same goes here. 3 fourths plus 2 fourths, adding my numerators gives me 5 fourths, or 1 1/4. But multiplying gives me 3 multiplied by 2 is 6. 4 multiplied by 4 is 16. Or simplified, there's 1 2 and 2, 2 2s and 4, 3 8s. So now as I look at it in a diagram, 1 2 3 fourths plus 1 2 fourths gives me 1 whole and 1 fourth. 3 fourths of 2 fourths. Here's 2 fourths. 3 fourths of them are just 1/8. Or 3/8, sorry. Less than 2 fourths, isn't it? Because I'm only taking 3 fourths of them. Or I can look at the fractions the other way too and say 2 fourths of 3 fourths. Well, 2 fourths is a half. So half of 3 fourths. Here's 3 fourths. Half of them will be right there. 3/8. So that's diagrams showing how multiplying and adding are different. How adding fractions give me something greater. When I'm multiplying fractions, I get something less. Now, as we get into mixed numbers, though, it can change. Let's do a generalized rule that can help us. When you multiply a whole number, W by another whole number, will the product be greater than or less than W? Now, this confuses me, so I wrote it out in an equation. Whole number multiplied by another whole number, is it going to be greater than that first whole number, or will it be less than the first whole number? So whenever I have a situation like this that's kind of confusing, I like to actually do it. Well, if my whole number was 3 multiplied by another whole number 2, that would give me 6. And 6 is greater than 3, so it would give me something greater than my whole number. Why is that? N is more than one group. It's 2 groups of 3. So it will be greater because you are combining more than one copy of W. I have 2 copies of W. I have 3 and I have another 3, so it has to be more. If I multiplied a fraction less than 1, AB, by another fraction less than 1, will the product be greater than or less than AB? So I said this. Would 1/2 multiplied by a third be greater than 1/2? Or would it be, oh, I should have changed this to less than. I made a mistake there. So I'm thinking, is it or is it less than? Well, 1/2 multiplied by 1/3 would give me 1 multiplied by 1 is 1/6. So it is less than, isn't it? So it will be less than AB because we are taking part of AB. 1/2 multiplied by 1/3. I'm taking a third of the half. I'm taking less than one whole group of the half. So I have to have less than half. So go ahead and give this page a try. What I suggest you do is either do the whole page and then, or pause my video, then do the page. But then when you start playing it, if you weren't quite right, or if while you're trying to do it you don't get it, watch me do one and then go back and do them. All right, so give her a pause. Welcome back. I'm going to do number 1. So number 1, here's my thinking. 2/5 multiplied by 3/4 equals something. Predict what is x going to be greater than, less than, or equal to 3/4. Well, x to me is going to be less than 3/4 because I'm taking 2/5 of the 3/4. I'm taking 2/5 of it. I'm not taking the whole thing. I'm taking less than the whole 3/4. So now I have to compute it. I know I can, 2 and 4 both have 2 as a factor. So there's 1, 2, and 2, and 2 2s and 4. 1 multiplied by 3 is 3, and 5 multiplied by 2 is 10. Am I right? Is x 3/10 less than 3/4? Yes, because tenths are smaller than fourths, and I have the same number of pieces. So I was correct. Okay, you can pause it and do these, check to make sure yours are reasonable, then take a look at mine. Let's take a look at number 2 now. 6/6 multiplied by 3/4 equals x. So is x going to be greater or less than 3/4? Well, let's see. I'm taking 6/6 of the 3/4. Well, 6/6 is equivalent to 1 whole. 1 multiplied by 3/4 is 3/4. It's going to be equal. And if I did it, let's take a look-see. Let's actually do it. Let's forget about my 1 whole that I made. Let's do it as fractions. 6 and 4 have 2 as a common factor. There's 3 2s and 6. There's 2 2s and 4. 6 and 3 have 3 as a common factor. There's 1 3 and 3. There's 2 3s and 6. 3 multiplied by 1 is 3. 2 multiplied by 2 is 4 for a denominator. x equals 3/4, so x does equal 3/4. Mine are equal. I was correct. Try it again. All right, number 3. 1 3/7 multiplied by 3/4. Prediction. Is x going to be greater than, less than 3/4? The product here. Well, 3/4. I'm taking 1 and another 3/7 groups of 3/4. I'm taking more than one whole group of 3/4, so it's going to be greater than 3/4. All right. So the first way I can do this is to make fractions. 1 whole is 7/7, plus 3 more would be 10/7, multiplied by 3/4. Change colors here. 10 and 4 have a common factor of 2. 2 multiplied by 5 is 10. 2 multiplied by 2 is 4. 3 and 7 don't have any common factors. 5 multiplied by 7 is 15 14ths, which is equal to, I can group 14 of those 14ths, make one whole, and I have 1/14 left. So I get 1 and 1/14. And that is greater than 3/4, so I was correct. Let's look at it the other way, or another way I could do it would be to use the distributive property. And it kind of shows me why I get more than 3/4. Because if I take 1 3/7 and I break it up into 1, or decompose it, I should say, into 1 plus 3/4, and then do my multiplying. Multiply the 1 by the 3/4. I have one group of 3/4. But I'm also taking another 3/4 of a group of 3/4. I'm taking more than one group of 3/4, and that's why I have greater than 3/4. Now, one group of 3/4 is quite simply 3/4. But 3/4 of a group of 3/7. No factoring. 3 and 7 do not have, only have 1 as a common factor. 4 and 3 only have 1 as a common factor. So 3 multiplied by 3 is 9. 4 multiplied by 7 is 28. Now I need to get common denominators to add, which 4 is a factor of 28. I have to multiply these both by 7, would be 21 27ths. And I'm just going to cross this one out. 21 27ths plus 9 27ths are 28ths, Mr. Springer, are 30 28ths. So 28 28ths make a whole. That's 1 and 2 28ths. And 2 and 28 could be divided by 2 to give me 1/14. So that's why it's greater than 3/4, because I had one group of 3/4 and then another 3/7 of a group of 3/4. Okay, let's move on. 3/3 multiplied by 2.5. Well, 3/3 is equal to 1, so I'm going to get 2.5. Sorry about that. Don't know why it freaked out on me. So it's equal to 2.5. All right, let's use the fraction form of it. 3/3 multiplied by 2 wholes is 4 halves, plus 1 more are 5 halves, equals 15/6. 15/6. Every 6 make a whole. 15 divided by 6, there are 2 6s in 15. 2 wholes would be 12. 15 subtract the 12s would be 3/6. And I know that 2 and 3/6. And I know that 3/6 is equal to a half. So I was correct in saying equal. 2 2/3 multiplied by 2 1/2. Is x going to be greater than, less than, or equal to a half? Well, I'm taking more than one group of 2 1/2, so it is going to be greater than 2 1/2. Let's try fraction form again. 2 wholes is 6/3 plus 2/3 are 8/3. Multiplied by 2 wholes is 4 halves plus 1 half are 5 halves. Eight and 2 have 2 as a common factor. 4 multiplied by 5 would be 20/3. Every 3/3 is a whole. How many 3s are in 20 would be 6. Would make 18 of the thirds I would use. I would have 2/3 left. 6 2/3 is greater than 2 1/2, so I think I was right in my prediction. 7/8 multiplied by 2 1/2. Is x going to be greater than, less than, or equal to 2 1/2? Well, since 7/8 is less than 1, it is going to be less, I believe. Fractions again, 7/8 multiplied by 2 wholes is 4 halves plus 1 half is 5 halves. I do not have any common factors here or here. 7 multiplied by 5 is 35. I do have common factors in 8 and 2, but they're both in the denominator, so it wouldn't be the same as making an equivalent fraction. Give me 16. That is greater than 1 whole. Every 16 sixteenths make a whole. How many 16ths are in 35? Well, double 16 is 32, so there's 2 16ths. 35 subtract the 2 sixteenths would be subtracting 32 sixteenths, leave me with 2 3 sixteenths. Now I have to do some thinking. Is 2 3 sixteenths less than 2 1/2? Well, half and sixteenths would be 8 sixteenths. 3 sixteenths is less, so yes, it would. Taking a look, 1 1/10 multiplied by 5, will it be greater than or less than 5? I believe it's going to be greater than 5 because I have one group of 5 and 1/10 of group of 5. And let me show you that in multiplying using distributive property. 1 1/10 multiplied by 5 is the same as saying I'm going to take my 1 multiplied by 5 plus I'm going to take my 1/10 multiplied by 5 1 multiplied by 5 is 5 plus 1/10 multiplied by 5. Awesome, this is a good one to show. When I'm multiplying fraction by a whole number, you might remember, since it's a unit fraction multiplied by a whole number, it's going to be my whole number over the denominator. Why is that? Because 5 is just a fraction, 5 over 1. And then 1 multiplied by 5 is 5, 10 multiplied by 10 is 10. However, in this, I can simplify 2, saying they both have 5 as a common factor. 1, 5, and 5, 2 5s and 10 would be 1 multiplied by 1 is 1. 2 multiplied by 1 is 2. 5 tenths is 1/2. 5 plus a half is 5 1/2. Woo! I was right. X is greater than 5. 5 1/2 is greater than 5. 9 tenths multiplied by 5 is going to be less than 5 because I have less than one whole group of 5. Change 5 into a fraction by putting it over 1. 9 and 1 only have 1 as a common factor, but 5 and 10 have 5. There are 2 5s in 10 and 1 5 in 5. 9 multiplied by 1 is 9. And 2 multiplied by 1 is 2. 9 groups, and it takes 2 to make a whole. So every 2 2s is a whole. I have 2, 4, 6, 8. I have 4 2s in 9 with 1/2 left. And I was right. It is less than 5. And that makes sense because when I had 1 and 1/10, I had a half greater than 5. Now I only have 9 tenths. I have a half less than 5. 10 tenths multiplied by 5, I believe is going to be equal to 5. Why is that? Well, one thing I could do is say, hey, 10 tenths is equal to 1 multiplied by 5, and 1 multiplied by 5 is 10. Or I could say 10 tenths multiplied by 5 as a fraction would be 5 over 1. Or 5/1, which I don't really ever say. 10 and 1 only have 1 as a factor, but 5 and 10 have 5. There's 2 5s in 10 and 1 5 in 5. 10 multiplied by 1 is 10. 2 multiplied by 1 is 2. Every 2 halves is a whole. There are 5 2s in 10, so it would be 5. Either way, I got 5 or equal. Now, what patterns do you notice? Take a look and see what pattern you notice. Okay, something if you're still struggling to find a pattern, when does the product become greater than its factors? When is the product less than the factors? Is it ever the same? So when does the product become greater than the factors? So if I look at this, greater than, here, here, and here. When did it become greater? When the other factor, here, here, and here, is greater than 1. 1 3/7 is greater than 1. 2 2/3 is greater than 1. 1 1/10 is greater than 1. When is the product less than the factor? Well, I have less than here. I have less than here. And I have less than here. Let's look at our other factor. My other factor from 3/4 is, let me grab my eraser quick. All right. So my other factor is 2/5 less than 1. My other factor is 7/8 less than 1. My other factor is 9/10 less than 1. So whenever we get a factor, or whenever we get a product less than one of our factors, it's because the other factor is less than 1. So all I have to do is always look at my other factor to see if my products can be greater or less than that factor. Let's see if it holds true for when they are the same or equal. So equal, equal, equal. Let me grab my eraser so I can see my other factor. My other factor, there's my other equals. Okay, so my other factor was 6/6 equal to 1. My other factor was 3/3, it's equal to 1. My other factor was 10/10, it was equal to 1. So it all comes down to your other factor. If your other factor is less than 1, your product is going to be less than the other number. If it's equal to 1, your product's going to be equal to your factor. If your other factor is greater than 1, your product's going to be greater than your factor. So when does that come into use? All right. Go ahead and do this, and then I'll talk about it. All right, you should have completed the statement with greater than, less than, or equal to. So did you get this? Multiplying any number n by a factor less than 1 gives a product n. So when I multiply any number by a factor less than 1, so if my other factor is less than 1, it is going to be, let's do this, less than n. Multiplying any number by a factor equal to 1. Well, any number multiplied by 1 is going to be equal to that number. And multiplying any number by a factor greater than 1 is going to give me something greater than that number because it's taking more than one copy of it. This is just review on equivalent fractions. Multiplying a fraction by a fraction equal to 1 gives an equivalent fraction. It is the same as multiplying both the numerator and denominator by the same number. 4/7 multiplied by 3/3 gives me 12/21. Why is that? Because I'm multiplying the numerators 4 by 3 to get 12, and the denominator 7 by 3 is 21. 12/21 is equal to 4/7. Multiply the fractions by a factor equal to creating an equivalent fraction. So I'm going to go back to my pens. So I'm going to multiply by another factor. So factor multiplied by factor equal to 1. Well, let's just use, in this case 4/4 because that's equal to 1. So that's going to give me a product equal to 4/5, but it's going to be 4 multiplied by 4 is 16, and 5 multiplied by 4 is 20. My pieces got 4 times smaller, so I need 4 times as many. All right, now 3/11. Let's try going another fraction. They use 3/3. We use 4/4. Let's use 5/5 here, because that's a fraction equal to 1. I'm going to have 5 times as many pieces. I have 15 pieces. So my pieces have to be 5 times smaller. 11 times 55 would be 50/5. And now this one I'm going to just use the shortcut or the littlest one, multiply them, numerator by 2, denominator by 2. So I'm multiplying by 1 in the form of 2 halves. I get 2 times as many, or my pieces get twice as small, so I need 5 times 2, twice as many. Making equivalent fractions by multiplying by 1 whole. All right, this will conclude lesson 9, video 1, and I'm going to make a new video for 2.